Hello students, Ms. Slyman here, and we're into section 3.5 in our syllabus. And so what we're going to look at today is Venn diagrams. So what we are required to know from our syllabus is the basic concepts of set theory. So elements, subsets, intersection, unions, and complements. Notice in exams, we're going to have no more than 3 subsets. So what this means is when we're drawing Venn diagrams, we're going to have at most 3 circles that overlap in some way. This symbol here means empty set, so a set that has nothing in it. It's emptied. All right, so let's look at these symbols. So this capital U is universe, and what it means is the set of numbers or objects that we're going to talk about in the problem. So it could be a set of numbers, people, objects, etc. So only the values that are within our universe are values that we consider for the problem. This funky looking E, that means element. So an element means that it's a member of the set. If I put a cross through it, that means not an element. So not a member of the set. So a member in this case is an individual number, person, or object. This symbol here comes from up here, that's complement. And really what the complement means is not. So for example, if I have this, A complement means not A. So anything that's not in A. As we've seen above, that's our empty set. And I think that one's self-explanatory. This symbol, that's our intersection. So intersection, I can think of like I'm putting my arms down, and it means I'm being very strict. My arms are down. I take only elements or members in both sets. So to be part of the intersection, you have to be in both things. So A intersect B means only objects in A and B. So I can think of that as a capital and. You have to be in A and B. The union is like my arms are up. So this one is union, and my arms are up. I'm willing to take anything. So I can be a member of either or both sets. So if I have A union B, it means all the members of A along with all the members of B. So you could be in A, or you could be in B, or you could be in both. So the union is very welcoming. This symbol here means subset. And it means that you're wholly contained in another set. The symbol here is the N, and what this means is the number of items or members. So this answers the question, how many? And we'll look at some examples of this further on. All right, the next thing we need to know are the different number sets. And you should know these already, but if not, that's okay, let's learn them. All right, odd numbers are numbers that are not multiples of 2. So I could say 1, 3, 5, -7, -11. Any of these numbers are odd, so they're not a multiple of 2. Even numbers are multiples of 2. 2, 4, 10, 0 is an even number. -22, so any multiple of 2. Prime numbers have factors that are only 1 in themselves. So 1 is not a prime number. The first prime number is 2, then 3, 5, 7. I skip over 9 because 9 could also be thought of as 3 times 3, whereas 2 is only 1 times 2, 1 times 3, 1 times 5. So the next one is 11. So these have only factors of 1 and itself. So I guess really factors should have come first. Factors are numbers that multiply to make the given number. So for example, the factors of 12 are 1 and 12, 2 and 6, and then 3 and 4. So I always want to start with 1, then 2, then 3, and keep going up until I start repeating myself. So all of these numbers I can multiply by another number to make 12. Multiples are we take the given number and then we multiply it by 1, 2, 3, etc. So the multiples of 12 would be 12, 24, 36, 48, etc. This n is our natural numbers. We start with 0, then 1, 2, 3, etc. Z are integers. These are the positive and negative integers. So 0, plus minus 1, plus minus 2, etc. Notice 0 is neither positive nor negative. Q are rational numbers. That means we can write them as a ratio. So any of these numbers can be a ratio. Like for example, 2 could be written as 2 over 1 or 4 over 2. But so are a half, or 0.3, or 0.6 repeating. Any of these numbers I could write as a ratio. R is my set of real numbers. So basically, every number you can think of is real. So pi is a real number, but I can't write it as a fraction. 5 is a real number. I can also write it as a fraction. I can also think of it as an integer and a natural number. So that's our introduction to Venn diagrams and number sets.